Good afternoon, classes. I'm Jake Nolan, and with me we have
Tyler Adams,
Jimmy Vodich.
Oh
yeah. Today we are going to have a bunch of highlights, and they will be awesome. It was super duper.
Our
amazing.
top 3 highlights were a hole-in-one golf shot, a tennis shot to the chest, and a tackle.
And that tackle will really scramble your brains like eggs. Really scramble your brains like eggs. If eggs were brains, this is what they would be, because they would be scrambled.
Scrambled.
Super
Not
scrambled.
sunny side up, scrambled.
Up first on our top 3 charts, we have the tennis ball hit to the chest.
Oh, that hurt.
Number 3.
Let's go! Yeah! 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 Yeah!
Bury him.
Ouch, Charlie. That really hurt.
I wonder how much force the tennis ball had when it hit him.
Why, Jake, I'm glad you asked, because to find the force of that ball hitting the guy, we'd have to take mass times acceleration. With a mass of 0.06 kilograms and...
0.06?
Yes, 0.06. And to find the acceleration, we take the velocity and divide that by time. And to find the velocity, we take the distance of 13 meters.
13, yeah.
13 or 12?
13 on the
Round
dot.
up to
13.
13 meters. And we take that and divide it by 1.3 seconds to find the velocity. And then we take that and divide it by the time of 1.3 seconds, and we get an acceleration of 7.69. 69.
Meters.
7.69 meters per second squared.
It is a nasty hit.
That was one nasty hit. And then we times that by the mass of 0.06, and that gives us a force of 0.46 newtons.
After using sig figs, right?
After using sig figs.
0.46. Ouch. Wow, that really hurt.
Charlie.
Golf isn't just for Tiger Woods and Mike DeGrazia. Check out Dan Dangus and his amazing hole-in-one shot.
Number 2.
Junior, bro! Oh my god, it's a hole-in-one!
Wow, that's a great shot.
I wonder how far that ball really did go.
Oh, I was wondering that too. Wow.
Well, you know, I can use physics to tell you guys. Would you like me to? Great, because I am.
Yes, sir.
Well, if you use
Sir,
the
sir.
equation, Vx equals Vo cosine theta, and you know that he hit it at probably an angle of, what, 50 degrees?
Probably, I would say so myself.
Yeah, and the
Probably.
initial velocity of the swing was probably 31.3. Then you plug it in, and you get Vx equals 20.1 meters per second. And then you use that to plug into the equation of dx equals Vx times time total.
Oh.
And you get
wanna
dx
go over
equals, yeah, and then you get dx equals 20.1 times 6.8.
6.8, because that's how long the ball took to land?
It is.
Oh, wow.
That's
God,
a great
cool.
guess, Jimmy.
Thank you.
Wow.
Thank you.
And then you
Hey.
get dx
Hey.
equals
Found it.
good pound, but the final distance was 136.8 meters.
Wow.
Yeah, that's
He-
pretty far.
He creamed it.
Dale Dangus? Yeah.
Oh!
No, Mom, you're going to have to get off the line. Thanks.
At numero uno, we have that spine-splitting tackle we were talking about before.
And we reserve
Green, 17. Yellow, 11. Put.
That guy got killed. I hope he had a Band-Aid.
Or maybe a body aid.
I wonder what the final velocity was of that inelastic hit.
Well, if you want to know, the equation to find that out is you do mass 1 times velocity 1 plus mass 2 times velocity 2. And then equals mass 1 plus mass 2 times final velocity. And the receiver in that weighed 61.2 kilograms as his mass, and his velocity was 0 because he was standing still at the time of the hit. The tackler's mass was 77.1 kilograms, and his velocity was 3.18 meters per second. And once you plug that into the equation, you get 245.18 equals 108.3 times the final velocity. You then divide the 108.3 on the other side, so you get 245.18 divided by 108.3, which gives you a final velocity of 2.3 meters per second.
Wow. He got hit.
You dropped something, dude.
That's a low
Shit,
price.
Wow.
Wow, that was a great show.
Yes, it was.
It was awesome.
Thanks for tuning in. We'll see you guys next week.
We'll see you next week, Crystal Lake.
Hold on. This is just in. Yeah. We got him. And then I told my wife, get back in the kitchen.